Are we, though?
Given triangle ABC,
Make sure you do your be real.
use point as the center of dilation to locate the vertices of a triangle that has side lengths that are 3 times longer than the triangle ABC. Okay?
You like am or
So we are going to use rulers here today. But before we do, how can we find 3 times longer? Like, what do I need to do?
You need to first measure what the lengths of A, C, B, C.
That is one way to do it, but I'm going to show you an easier way because we need it to be exact. We need to construct it, yes?
the distance between like points M and A?
Yeah, so the distance between point MA.
Mr. Ball, real quick, can I just say the like lamb thing that I was telling you about? This is exactly what I did with it.
Oh, nice.
It's to
Sweet.
figure out how big to cut the circle.
Yeah, that's
This is what I
perfect.
exactly did.
That's amazing. Great. So you're going to measure this distance, okay? And then you are going to, how much bigger did we say we needed it to be? So you are going to multiply that distance times 3. Okay? So if that red is a distance of x, because it will be all this, it should be all relatively the same for you guys, but it would be different for me. Then the blue line should be 3x. Sorry, let me put this one back in red. There you go. Now you can see both. Okay? That is A prime. Oops.
I don't know what she's thinking.
How's it go?
That is A prime right here. And then you also need to do C prime and B prime and then connect those lines. Okay? I would also recommend using millimeters and centimeters with a ruler instead of inches.
Wait, is she getting our shirts?
I have no clue.
I don't know. She is?
No.
I don't know.
Oh, okay.
I went like this. and she-
Oh.
I went like
So
you have yours and-
that is what we are doing. Does anyone need a ruler?
Yes.
Okay.
Sure.
So we're gonna have to be kind of efficient in sharing these. Okay.
Gimme.
You guys just making that up? She's not even there.
She was there.
Am I being gaslit?
Give us
No.
a shirt. Give her.
If we were gaslighting you, it would be something much more hilarious than just housing there.
Smokey the Bear. Okay, go ahead and do that. All right, once you have finished that, you're going to do the same thing with n, except for this time, instead of multiplying, it says we need to have the center of dilation be n with side lengths that are 1/2 the length. So what do you think we should do?
Divided by 2.
Divided by 2. Very good. Pitter patter, let's get at it. And we're live.
Joker?
Okay, let's get started.
Okay. All right. Okay.
Okay, so.
Okay. All right. Okay. So, okay.
It's enough
Okay.
slices.
It's enough slices.
All right. So, as you can see, we have drawn up here these figures, right? A prime, B prime, C prime is 3 times as large as A double prime, B double, as ABC. And then A double prime, B double prime, C double prime is half as large, right?
I was like,
Okay.
that's only one.
No, it's double.
You have those ones larger.
So,
Only one.
what I want you to do, and this is what number 3 is requesting, is you need to create some proportions about this, okay? So you can create up to at least 10, okay, that you believe are true.
What do you
So proportions might be like, here's a first one. Here's like a little hint. A prime, B prime over AB is equal to A prime, C prime over AC. Okay? Because I'm taking this right here over this is equal to this divided by this. Okay? So I'm taking proportions of triangles. Now, here's one that you haven't probably thought about so far, but you can actually take these line segments from M as well. So I could say m to a prime over ma is equal to m to b prime over mb. So I can use those points of dilation as proportions as well. Okay, so there are 2 proportions for you. You need to find at least 8 more. You can also go, because proportionality deals with similarity, right? We acknowledge that. Jacob?
Are the ones on the bottom for the M, A prime, are on the right line? I was gonna ask if they're also prime.
Gotcha. Okay, so proportionality statements deal with similar triangles. We would say that ABC is similar to A prime, B prime, C prime, right? Okay, because that's what we dilated it, right? Yeah, we just expanded it. Now, ABC is also similar to A double prime, B double prime, C double prime, right? Okay, so this is similar to this is similar, and this is similar to this, right? Yes, so that must mean also that A prime, B prime, C prime is similar to A double prime, B double prime, C double prime. So let me give you one more. I could even say A prime, C prime over A double prime, C double prime is equal to B prime, C prime over B double prime, C double prime. And that would be a true statement as well. Yes.
I forgot a thing. You need to put.
Oh, yeah, the segment lines. I did that over here as well.
So
Zoops. Yeah, the little segment marking. Okay, so there are 3 proportionality statements. Now I want you to find 7 more. Okay?
Wait, let's do one more.
Let's do.
All right. Y'all that are up on the YouTube,
Can you?
here's a chance to. Yes, I will move it up for you. Here, I'll move it up for you on the YouTubes as well. What other ratios do you guys have? Yeah, Jacob.
Segment C prime, A prime over segment C double prime, A double prime is equal to segment C prime, B prime over segment C double prime, B double prime.
Great.
Ours.
Yeah. Jason?
Line BM over line BN is equal to line CM over line CBN. Sorry, CM over CN. Words are difficult. BM over BN is equal to CM over CN.
Let's see. BM over BN. Yeah, that should be right. Good. It's probably one that y'all didn't have. Any others?
Yes.
Here, let's see.
Would AB over A double prime, B double prime equal BC over B double prime, C double prime?
Yeah. Good. How about
I got one.
NA double prime over NA?
Equals NB double prime over
Sure.
NB?
Yeah.
What else? Can you do like to C? Can you make it like a different one or can you just do
Yeah.
I'm doing NB double prime over NB equals NC double prime over NC.
Great. Tayson, do you have one more?
Give me a sec.
So loud. Why is the pop so loud?
Wildin'.
Is NB over NB prime equals NA over NA prime thing?
What? Well, heck yeah, dude. Noise, 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 noise. Yeah, one more.
I did it.
Wait, we have 10. Oh, wait, no.
Jacob wanted to share one more.
That doesn't mean you
I
have
wanna
10.
check, because there was two I had, but I don't know if they're,
Okay, let's see.
so segment NB prime over segment NB, and then NC prime over MC.
Yep.
And then there was also B prime, C prime over B double prime, C double prime, and B prime, A prime over B double prime, A double prime. Now I'm
Say the second one again.
B prime, A prime over B double
Yes.
prime.
Yep. Great. Cool. So you can now see that we can go from segments of dilation to sides of dilation to all sorts of stuff, right? And if similar triangles are similar to one triangle, they're also similar to each other, right? So like A double prime, B double prime, C double prime is similar to A prime, C prime, A prime, B prime, C prime. Why does it do that?
Do what?
It's like goes pale and then a color again.
You never noticed that
Don't
about
do
your
that to
skin?
yourself.
I don't think
I'm
mine does that.
Yeah, it
just-
should.
I'm just
I would
finding.
hope it does.
I'm just finding
It
out
sh-
my.
It
should
really
have
should.
blood,
It's like when you do it to your
Okay.
fingernails, like if
Wait.
you squeeze your fingernails.
We got to go on. Here we go. So, based on your work above, under what conditions are the corresponding line segments in the image and pre-image parallel after dilation?
It is always.
It is always. So, like, it's asking, is A, B parallel to A prime, B prime parallel to A prime, B, A double prime, B double prime? Yeah, they're all parallel, right? C prime, B prime is parallel to CB is parallel to C double prime, B double prime. So we could say it's always parallel. Now, why? I have written up here, the angles created that are corresponding are congruent. So what I'm looking at there is like, if I were to look between A and A double prime, this angle and this angle are corresponding and they're congruent. Okay? If I wanted to look between C prime and C, I mean, I've got it drawn poorly, but like those two on your papers will be congruent because they're corresponding. So if they're corresponding and congruent, that means those line segments are parallel. So you can say yes, because the angles that are corresponding are congruent.
That's for number 5.
Mm-hmm. Okay. Now this next one, we're going to use point A as the center of dilation to make A, B prime, C prime with side lengths that are twice as long. So how can I do that?
Well, A would say A
Mm-hmm.
prime.
So what do I need to do for AC to get AC prime?
Double it.
Measure and double. Yep.
Measure.
So how could we use the diagram that we created to prove this theorem? The segment joining midpoints of two sides of a triangle is parallel to the third side and half the length. What do you think? So it's saying that AC, this is what it's asking. AC is equal to 1/2 AC prime. And it's saying that CB is parallel to C prime B prime.
angle have to add up to 180, and we have both of those lines, right? They're just extensions. Those angles are kept the same. And so since all the angles are the same, they have to be parallel because the angles they're meeting at, those two lines, are the same.
So angle B is congruent to angle C, or angle B prime, right? And angle C is congruent to angle C prime. Right? Not double prime. What is happening? Very good. So if that's true, oops. Then we could also say that because of corresponding angles, right? CB is parallel to C prime B prime. Now, how about this? How could we say, oh, really what they're trying to say is they're saying that we have this, but now they're trying to say, okay, how could I say that BC is equal to 1/2 B prime C prime? That's what we're really trying to say. So we've said they're parallel now over here. How could we say that the 1/2 the length?
I mean, well, we can use the fact that the scale factor for a dilation has to be constant throughout the shape. And so if the scale factor results in AC being half of AC prime, then BC would have to be half of BC prime since they're...
So we could say 2AC is equal to AC prime, right? Let's do it this way. So that must mean 2BC is equal to B prime C prime, right? If we divide both sides by 2, then we get BC is equal to 1/2 B prime C prime.
Quick.
What did I forget? Oh my goodness.
I remember that. I was just not gonna say it.
Oh no, segment markings. Segments. All right, there we go. Okay, I'll give you guys a little bit of time to work on your homework now.
That's it?
That's it for this lecture.
Oh, goodness.
Wait, we're not doing the second one, or?
We might in a little bit.